Now, since logarithmic functions are the inverse of exponential functions, the properties that go with logarithmic functions are very similar to the properties of exponents. So to be honest, you already know two of them. So for example, when you're multiplying, what is it that you do with your powers? You add them. So this relates back to logs in that same way. When you have the product property, when you're multiplying here, you can separate that and write that as the addition or the sum of two different logs. So if I wanted to expand this, which is something you'll be asked to do, I could break that into the log of x, and since that's being multiplied there, plus the log of y. Now going backwards, because you have to be able to use these properties both ways, going this way to here and this way to here. So condensing from here to here, if I have the sum of two separate logs, as long as their bases are the same, I can write that as the product using one log. So if I'm trying to condense the log of 2 plus the log of x, that'll give me the log of 2x. Okay, quotient property. This is the other one you know. When you're dividing, what do you do with your exponents? You subtract. So if you're taking the log of something divided by another thing, then you can rewrite that as the expanded version of the log of the thing on top, subtracting the log of the thing on bottom. So if you were to expand this, now ln is just another type of log. It's natural log, and we will go into that more another day. But it's treated just like log. So you write the ln of x, natural log of x, and since it's being divided there, minus, because division means subtraction in these cases, the natural log of 4. Condensing means we're going from the expanded version to the squished version. So when you see subtraction, that means you can write it as a fraction. So this starts off as log, and the way I think of it is anything with an understood positive in front of it goes in the numerator, and since these both have minuses in front of them, these go in the denominator. And then once you have it written as that, it can be reduced to the log of 4 over x. Let's get this clear. Alright, power property. Now this is the coolest property ever. This is what allows you to solve for variables when they're up in the exponent spot up here. So up until now, you've had really no way to solve for that up there. If you have the log function there, you're allowed for the power to drop down in front. And that's just amazing. And you'll use this tomorrow to start solving equations that have the exponential and logarithmic equations. Okay, so we're trying to expand log base 5 of x squared. That means that this 2, since it's the power, is allowed to hop down in front of the word log. So this becomes 2 log base 5 of x. And condensing it means the other way around. You're going to take whatever is in front, whatever's numbers in front of a log is truly the power of the thing it's taking the log of. So this 2 here will hop up here. So this becomes the natural log of y squared. And this is really the only property that's new to you, and you're going to use that a lot in solving. Alright, then of course it's not all this simple. This is each property separate. Now, like putting them all together, when you're expanding, it's a good idea to break it down first using the product and quotient property. So initially this would be log base 3 of 5. And since that's being multiplied there, that'd be plus log base 3 of x. And since that's being divided, that's minus log base 3 of y squared. And then in your final answer, you need to make sure you do that power property and bring your power down in front. So your final answer to this one would be log base 3 of 5 plus log base 3 of x minus 2 log base 3 of y. Condensing, it helps to do your powers first. So you generally are going to put the power up first. So I have those numbers in front, remember, which are just powers. So the first step to do is to say that this is the natural log of x minus the natural log of y squared plus the natural log of z to the fourth. And then now that I have all my powers up there, I'm going to write this as one natural log, because condensing it means your final answer is going to be just one log. And then anything that has a plus in front of it goes on top and minus goes on bottom. So x goes in your numerator, y squared because of that minus goes in your denominator, and then z to the fourth because it's got a plus goes up top. And so that can be condensed as the natural log of x z to the fourth all over y squared. Not all over, the x z to the fourth is over y squared. And that is it for properties of logs.